Now let's see how our level-wise traversal function actually works step by step on our input tree. Okay. So first thing that is going to happen is I'm going to call my function with the address of 10. So I'll write our call as level wise 10. Okay. Again, this is going to be address of the node. And then we come and ask question, is our node null? It is not null. So we have to do the processing. So we create a new queue of the size equal to total number of nodes in my tree. So it is 1, 2, 3, 4, 5, 6, 7. So I'll create a queue with 7 possible slots. So let's create this queue with 7 slots. So I have 1, 2, 3, 4, 5, 6, and then there is its 7th. Fine. So we created it. It is empty. This is the head of my queue, and this is the tail of my queue. Fine. And then what happens? Then I'm going to add my current node. So 10 comes here to the queue, and then we start iterating through our while loop. So is our queue empty? It is not empty. There is one element in our queue. So I'm going to delete the element from queue and store it in the current. So let's keep track of our variable current. Okay, so current is now equal to 10. And then we are going to perform the traversal specific task. Let's say we are just going to print current.val. So in all these examples, we are just printing the contents of the node, but it's not necessary that that's the only thing that you do. You can do any task that you like. So that is something depends on why you are doing the traversal. So now what I have to do is I have to print the current value. So I'll mark that this value is now printed. Okay, so 10 is printed. And then I check if the current nodes left is not null. Yes, it is not null. I have 20. Then I have to add it to the queue. So what I will do is I will add 20 to my queue. It will be in the slot 0. And then I have to check if I have the right child for current node. Yes, I do have. So I will add 30 here. Okay. And then I reach to the end of the loop. I go to the beginning, ask question, is my queue empty? My queue is not empty. So I delete, and now my current becomes not 10, but it becomes now 20. And then I have to print 20, which is the next statement. So I will mark that 20 is now added to my output, and now 20 is gone from the queue. Fine. And what is the next thing to do? Check if my 20 has a left child. Yes, in that case I'm going to add my left child to the queue. So 60 comes to the queue, and then I have to add the right child if it exists. So 50 comes to the queue, and that's where I reach to the end of the loop. I go back to the beginning. I ask my question, is the queue empty? It is not. It has 3 elements. So I start deleting an element from the queue, and the element that I get is 30. 30 is gone, and now my current becomes 30. So with 30 as the current, first thing to do is print the value. So now 30 is printed in the output, and then we check if 30 has a left child. It does have. So I'm going to add 40 to my queue, and then I ask question, does 30 have a right child? It doesn't. So I won't add a null to my queue. And then I'm done with processing of node 30. I reach to the end of the queue, and I go back to the beginning of my loop. I ask question, is my queue empty? It is not. There are 3 elements. I delete the first element, which is 60, and now my current is 60, and then I have to add 60 to my output. So I added 60 to my output, and now I'm going to check if 60 has left child or right child. Both of them are absent because 60 is a leaf node. So I won't add anything, and I have reached the end of the loop. I'll go back to the beginning of the loop, delete next element. So I'll delete now 50, and my current becomes 50. And first thing I have to do is add 50 to my output, and then ask question if 50 has any child. Again, 50 is a leaf node, so there is nothing to add. So I have reached the end of the loop while processing 50. I'll go back to the beginning of the loop. Is there anything else in the loop? Yes, there is 40 in the loop. So now I will delete 40. So my current will become 40. First thing to do is print it. So now 40 is added to my queue. And then I ask question if 40 has a left child. Yes, it does. So now 40 is gone, and the first thing to add to my queue is it's 70. And then what is the next thing to do? Is 40 having a right child? It doesn't have. I reach to the end of the loop, go back to the beginning, and ask question if queue is empty. It is not. There is one element. I delete that element from the queue. So my current becomes now 70. This element is gone. I add 70 to my output and check if 70 has any child. It doesn't have, so I don't add anything to the queue. I come back to the beginning of my loop and check if my queue is empty. Indeed, my queue is empty, so I'm done with my level-wise traversal. So we got the exact same output that we wanted, and that's how the level-wise traversal works. Now, next curious thing to ask is, do we really need a queue of the size of the number of nodes in my tree? Okay, or can you tell me a better way to decide the size of the queue that will be required? Okay, so if I have the queue of the size of total number of nodes in my tree, well, that is always going to work, but some capacity in the tree would be definitely wasted in that case. Okay, so think about it that at any point of time, at the most, how many nodes would be pending in my tree? And if you can't get the answer, of course, we'll discuss these questions in our discussion session each Monday.